let's take a moment to investigate the derivative of inverse trig functions. All right. So remember, inverse trig functions are things like inverse sine, all right, sine negative 1 of theta, or let's just call it x. So we have inverse sine of x. And we can also write as arc sine of x. All right. So arc sine, inverse sine means the same thing. Sometimes we avoid this. We like to write arc sine because that negative 1 gets a little cumbersome. There, it's not really a power. It's just a notation. So arc sine is a little cleaner sometimes. Anyways, well, we're talking inverses here, and we want the derivative of an inverse. And so we're going to want to use our rule. All right, so our rule that we know for inverses, and that is this: if f and g are inverses, then we know the derivative of f at x is equal to the reciprocal, or 1 over the reciprocal of the derivative of its inverse function g, composed of f of x. All right. Now, we can write this in, since f and g are inverses, you could also write this as the derivative of g is 1 over f prime, the derivative of f composed of g of x, or evaluated at g of x. All right, same thing. So the key is this. Here we have a function. Usually this is a function we don't know how to find the derivative of, or it's not easy to find the derivative of. But we can find the value of g of x. We can find the value of g of x, but not the derivative. Okay, so we don't know how to find the derivative of g, but we can find the derivative of its inverse. That's why this is useful. Okay, that's what this is saying too. Same thing, just letters flipped around. All right, well, let's investigate. We'll come up with these rules here in just a second. So we're going to kind of ignore those for a moment, and we'll come back to them. All right. So what about the derivative of arc sine? Let's start there. The derivative of arc sine of, let's just say x for the moment. All right. The whole u thing up there, right, is for the chain rule, right? Okay, so let's say this. Let's call f of x the arc sine of x, and its inverse g of x is sine of x. They are inverses of each other. All right, so we're going to be using this form right here. Again, they're equivalent, just different letters, but we said f prime, that's arc sine, all right? So we're looking for the derivative of this. So let's write our expression. So the derivative of arc sine of x, that's what we're looking for, is equal to 1 over g prime. All right, well, what is the derivative of sine? We can do that. I don't know the derivative of arc sine yet. We're not familiar with it. We're not using it. We're trying to find it. But we do know the derivative of sine. So g prime of x is derivative of sine, which is cosine of x. All right. So we're going to go cosine of x. Cosine of, because we want the derivative of f. So we're going to put f into the derivative function. All right, so let's go ahead and put arc sine into that cosine. All right, well, what does this mean? It's kind of messy. Cosine of the arc sine? What? Well, we got to go back to the definition of sine and cosine and arc sine. What does that mean? Well, remember, going back to right triangles, arc sine means this is an angle. Remember, inverse sines and inverse cosines, or arc sines and arc cosines, they find angles. So the arc sine of x defines an angle. All right, or if we flip this around, what this means is that we have some angle theta. There is some angle theta And if we take the sine of that theta, we get x. Or if we want, x over 1. So that means if we have this, we got some triangle that exists, and the sine, what is sine? Remember SOHCAHTOA? SOHCAHTOA. Sine is opposite over hypotenuse, right? So we have opposite over the hypotenuse. So there's some angle in a right triangle that has an opposite of x and a hypotenuse of 1. All right? And we got this side that we haven't even talked about yet. So let's go ahead and let's find this using the Pythagorean theorem. All right, we'll work it out. Let's call this side A. I don't know what that is, but a squared plus x squared equals 1 squared. Pythagorean theorem. So this is 1, because 1 squared is 1, minus x squared. And so a is the square root of 1 minus x squared. All right, so this mystery side here is just the square root of 1 minus x squared. All right, now let's go back to our expression here. We are looking for the derivative of arcsine. This is 1 over the cosine of the arcsine. Okay? So arcsine, we said here, we kind of defined it as some mystery angle theta. Okay? And then we drew the picture with this theta. So let's rewrite this as 1 over cosine of theta. All right. Well, what is the cosine of theta? Well, the cosine of theta is adjacent over hypotenuse. So cosine of theta down here is the adjacent, which is square root of 1 minus x squared, over the hypotenuse, which is 1. So obviously that simplifies 1 minus x squared. So the cosine of theta is just 1 minus x squared. And so we can say this is 1 over the square root of 1 minus x squared. And there we go. We found it. So the derivative of arcsine of x is equal to 1 over the square root of 1 minus x squared. So you won't necessarily have to remember all the steps here, but it is useful to have an understanding of where this comes from. This comes from the fact that we need to use a right triangle to get this. And when you look at this, hopefully you see the Pythagorean theorem. Sine is opposite over hypotenuse. That's where this x and the 1 came from. That was a hypotenuse and an opposite. All right, that's where that came from. And so this is the third side when the sine is x over 1. You can think of it that way. So there is the derivative of arcsine. Arccosine is the same kind of idea. Notice the only difference between arcsine and arccosine is a negative. So cosines are negative. In fact, notice all the cos are negative. Cotangent, negative. Cosecant, negative. Cos are negative. All right. So there you have it. All right. And so, again, just remember this comes from the Pythagorean theorem. That will help make some sense out of it there. All right. I'll show you real quickly the arctangent. You may want to try it on your own, but let's see. We'll do a quick version here of the derivative of arctangent. And if you want to try it out for yourself just for kicks, then you can pause the video and try it out. You're going to need a triangle. Whoops. Let's get our triangle over here. So if we say f of x is the arctangent of x, then g of x is tan x. All right. And we know our inverse function rule. F is what we care about. So we're looking for the derivative of f. That's 1 over the derivative of g evaluated at f of x. Again, I don't know how to find the derivative of f, which is arctangent, but I can find the derivative of g. And so we're going to put f of x inside of g prime. All right, so while we're at it, let's evaluate g prime. G prime, the derivative of tangent x is secant squared, right? Okay. Get this in a bit. So let's write it out here. And we have the derivative of arctangent of x is 1 over the derivative of the inverse, the derivative of tangent, and that is secant squared. So secant squared evaluated at f of x. What is f of x? It is arctan. And we're going to go to our triangle. We're going to say that arctangent, we know that arctan finds an angle. Arctan is theta. And so what that means to us is that tangent of theta is x over 1. That means we have a triangle with a tangent of x over 1. All right? And we're going to need this mystery side here. So using the Pythagorean theorem, you can call this c if you want. 1 squared plus x squared equals c squared. So this is going to come out to be the square root of 1 squared plus x squared. Because the Pythagorean theorem is 1 squared plus x squared equals c squared. So there's the third side. All right, well now we can come down here and we can say that this is equal to 1 over secant squared of arctangent, but we just said that arctangent is theta, so we'll call this the secant squared of theta. Just swapped out this arctangent here. Okay, arctangent, swapped it out for theta. All right, and well, what is the secant of theta? Well, the secant of theta is the square root of 1 plus x squared. We don't need this squared anymore there because 1 squared is 1. And we're going to take that whole thing. Remember that secant squared just means find the secant and square it. So there's the secant. We're going to square it, and that leaves us with 1 over 1 plus x squared. And that is the derivative of arctan. All right? Okay. So that's where that comes from. So again, the connection's useful. When you look at this, you should see the Pythagorean theorem. And why is it 1 plus x squared? Well, it has to do with the tangent. Remember, tangent is the two legs. So if you kind of remember this journey we just took, these two things added makes this. And where did the square root go? Well, that has to do with the fact that the derivative of tangent is secant squared, so that square root disappeared. So even if you don't or are not able to reproduce all this, if you kind of remember those facts, then it helps you remember that derivative of arctangent is 1 over 1 plus x squared and gives you a little reason for why this is. All right? So these are functions you need to remember. Now, you really only need to remember 3 of them because notice these are all negatives, the cos. So you just need to remember 3 of these, and when we go for the cos, make it negative. All right? There you have it. That's where we get the derivative of inverse trig functions, going back to the right triangle. All right, great job. Thanks a lot.